plus root of x power 4 plus a power 4. Okay, so I'm multiplying by this. Therefore, I should divide by the same quantity as well. So denominator will be root of x power 4 plus x square a square plus root of x power 4 plus a power 4. Okay, so this is equal to limit x tends to infinity. So this numerator is of the form a minus b into a plus b, which will be a square minus b square. In the denominator, which provides us one basis. So this is by this answer, which is also option. Okay, then let's have a look at the next question, which is question number 50. Limit x tends to infinity 2x plus 7 sin x divided by 4x plus 3 cos x. As it is, if I apply the limit as x tends to infinity, first term will be infinity plus the second term will be 7 into sine infinity, which we don't know what is its value. That limit does not exist. So infinity by infinity you get, which is an indeterminate form. We can go for L'Hospital's rule. L'Hospital rule also can be used. Instead of that, it is better if you divide by x. Divide both the numerator and denominator by x. Dividing by x here will give you limit x tends to infinity. When I divide by x, this will become 2. Here you will have 7 into sin x by x divided by, this will be 4 plus 3 into cos x divided by x. Now, as x tends to infinity, what happens to sin x by x? Limit x tends to infinity, sin x by x is equal to 0. See, as soon as you see sin x by x, immediately you will think, sir, it should be 1. It is 1 provided x is approaching 0. But here, in this particular problem, this x is not tending to 0. This x is tending to infinity. When x tends to infinity, sin x by x, right? Into sin x minus x infinity sin x, which is value, but we know something between minus, which is a finite t, so 0 is the finite quantity. So similarly, limit x tends to infinity, cos x by x 0. So the second term here in the numerator as well as in the denominator, these two terms will become 0. This is 0 and this is 0. So answer will be divided by 4, which is equal to 1 by 2. That's the correct. At 52nd question, this was asked in last year's CET question, CET paper. X tends to 0, tan x divided by root of 2x plus 4 minus 2 is equal to. Okay. So tan x by root of 2x plus 4 minus 2 is equal to. If I directly apply the limit here, tan 0 is 0. Denominator root of 0 plus 4, that is root 4, which is 2. 2 minus 2, 0. Numerator is 0, denominator is 0. So when you say 0 by 0, usually we'll think of L'Hospital's rule. Yes, that is what we are going to do now. Use L'Hospital's rule. What does it say? It says that you differentiate both numerator and denominator separately, not by using quotient rule. So derivative of tan x, which is secant square x, divided by the derivative of root of 2x plus 4 is 1 by root of 2x plus 4 into 2, into the derivative of 2x plus 4, which is 2. So this 2 minus x, 1 minus x. Okay. Okay. The base example will be 1 minus 0 is infinite. So directly get it 1 if we have to get okay. So if it is of the form, then this if it is when I apply 1 power infinity, if we get 1 power infinity, then this into x minus, so like formula we used on okay by now. So that then equal to our limit x to a, which is g of x 1 minus of x f of x minus 1. That's x as 1 minus 1. So that you will have the power limit x to mean by plus 1 minus x. So here and plus the limit as x1. When I put x as 1 here, we are going to get minus e power x the first option. E power 1 by 2. That's the first option. Okay. Look at the next question, which is question number 55. 55. Limit n tends to infinity pi n to the power 2 by n is equal. Limit n tends to infinity pi n whole power 2 by n. Here if we directly apply the limit pi into infinity, that will be infinity. Power 2 by n is there. When I put n as infinity, 2 by infinity, that will be 0. It will be to the infinity power 0. Don't write this as 1. So you have been told that anything to the power 0 is equal to 1. True only when anything is infinite, so you can't do that. Infinity power 0 is an indeterminate form. Okay. So now for this particular problem, we have to use a different method which we haven't used for any of the problems, that is by taking log. So before that, I'll call this as y. Let y is equal to limit n tends to infinity pi n to the power 2 by n. Okay, take log on both sides. Log y is equal to log pi to the 2 by. Okay, that's it. Log y is equal to property of logarithms, property of limits. That is log of limit x tends to a f of x is equal to limit x tends to a log f of x. Okay. So what it tells us is that this log and limit can be interchanged. Log x tends to a f of x is equal to limit x tends to a log f of x. Log of limit x tends to a f of x is equal to limit x tends to a log f of x. Okay, so that by using that property, I can interchange a log and limit here. I can write this as limit n tends to infinity log pi n whole power 2 by n. Log pi n whole power 2 by n. That's equal to limit n tends to infinity. So this looks like log m power n. Log m power n is equal to n log m. So it will be 2 by n log pi n. Log infinity in the numerator. Is infinity. Log infinity. Log infinity is so infinity. You just have a look at the graph of x. The graph of log x will look like this. It will go in this way. At x equal to 1, log 1 is 0. At x equal to 0, not defined. So from 0 to 1, it is negative. So it lies from both. So now as we increase the value of x, value of log x, as you can also goes on increasing. So by the time this x reaches infinity, log x will also reach infinity. So limit tends to infinity log pi n will be log infinity, which is also infinity. Numerator is infinity, denominator also infinity. Infinity by infinity is an indeterminate form. There we can use L'Hospital's rule. So this is equal to limit n tends to infinity 2 into 1 by pi n into pi divided by the derivative of 1, which is 0. So pi gets cancelled. You will have limit n tends to infinity 2 by n. 2 by n will be equal to 0. Don't write 0 as the answer. What they had given? They had given y. I mean, we have taken y. We were asked to find the value of this. We got 0 as the answer. It is not y. It is log y. Log y is equal to 0. So if log y is equal to 0, this will imply that y is equal to 1. Log y is equal to Okay, I have a question, which is question number 56. Limit x tends to infinity, a power 1 by x plus b power 1 by x plus c power 1 by x divided by 3. A power 1 by x plus b power 1 by x plus c power 1 by x by 3 whole power x, where a, b, c are real and non-zero is equal. Okay, so there is a shortcut here for this. Direct answer will be equal to a, b, c to the power 1 by 3. The second option is the correct answer. Okay, I'll give you the actual method first and then I'll explain what is that shortcut. Okay, so if we directly apply the limit, see what we are going to get. If I apply the limit as x tends to infinity, a power 1 by x we have 1 by infinity, that will tend to 0. A power 0 you get, which is 1. Here b power 0, that is 1. C power 0 is 1. 1 plus 1 plus 1, you have 3 by 3. So this will be 1 and power is infinity. When we directly apply the limit, it is of the form 1 power infinity. When it is of the form 1 power infinity, immediately we use this formula e to the power limit x tends to infinity g of x. What is g of x? X into f of x minus 1. F of x is a power 1 by x plus b power 1 by x plus c power 1 by x f of by 3. This is f of x minus 1. Okay, that's equal to e to the power limit x tends to infinity. Here x into a power 1 by x plus b power 1 by x plus c power 1 by x minus 3 whole divided by 3. That's equal to e to the power limit x tends to infinity a power 1 by x plus b power 1 by x plus c power 1 by x minus 3 divided by, I am taking this x to denominator, it will become 3 by x. Now if I take the limit as x tends to infinity, 1 by x will be 0. So a power 0 plus b power 0 plus c power 0, each of which will be equal to 1. 1 plus 1 plus 1, that is 3, minus 3, that is 0. Numerator is 0. Denominator as x tends to infinity, 3 by x, that also tends to 0. So this is of the form 0 by 0. So 0 by 0, therefore I'm going to use L'Hospital's rule. Derivative of a power 1 by x is a power 1 by x into log a into the derivative of 1 by x, which is minus 1 by x square. Similarly, the derivative of b power 1 by x is b power 1 by x into log b into minus 1 by x square. And in the same way, that third term, when we differentiate, will give us c power 1 by x into log c into minus 1 by x square. Minus 3 is there, whose derivative is 0. Denominator 3 by x is there, its derivative will be minus 3 by x square. So now I will take minus 1 by x square as common. I'll take minus 1 by x square as common. And that gets cancelled. Then we are left with the e to the power limit x tends to infinity. After cancelling that minus 1 by x square, we will have a power 1 by x log a plus b power 1 by x log b plus c power 1 by x log c whole divided by 3. We have cancelled that minus 1 by x square. Now apply the limit as x tends to infinity. When x approaches infinity, 1 by x will tend to 0. So a power 0, that is 1. So here log a, here log b, here log c. E to the power log a plus log b plus log c divided by 3. Log a plus log b plus log c can be written as e power log of a, b, c whole divided by 3, which is equal to e to the power 1 by 3 log ABC, right? Now it looks like n log m. N log m can be written as log m power n. So this will be log ABC to the power 1 by 3. This is equal to 1 by 3. As you know, e power log f of x is equal to f of x. So e power log, sorry, this is not 1 by 3. This is equal to ABC to the power 1 by 3. E power log is equal to f of x. Exponential and logarithms, they are the inverse of each other. E power log f of x can be written as f of x. So e power log ABC to the power 1 by 3 will be equal to ABC to the power 1 by 3. Okay. That's the actual method, but you don't have to stick to the actual method. I'll give you one shortcut. I will explain here. It is there in the synopsis also. Let's just go there to the synopsis. Look here. Limit extends to infinity. A1 power 1 by x plus A2 to the power 1 by x plus A3 to the power 1 by x, etc. up to An to the power 1 by x by n whole power x is equal to A1, A2, A3 and An product whole power 1 by n. So limit extends to infinity. What they have given here is here it was not visible properly. So limit extends to infinity A1 to the power 1 by x plus A2 to the power 1 by x plus A3 to the power 1 by x, etc. till An to the power 1 by x divided by n whole power x is equal to A1 into A2 into A3, etc. till An whole power 1 by n. This is a formula you should remember. Now you see in place of n we have 3, and in place of A1, A2, A3, etc. we have A, B, C. So by using this formula, A1, A2, A3 up to An. So in this case, A, B, C whole power 1 by n. N is 3 here. So A, B, C whole power 1 by 3 is the answer, which is the second option. Okay. So if you know this formula, directly you can write the answer. In case if you don't know the formula, this is what you have to do. Okay. So let's look at our next question, which is question number 58. Limit extends to pi by 4 tan x to the power tan 2x. Okay. Limit extends to pi by 4 tan x to the power tan 2x. If we directly apply the limit, we are going to get tan pi by 4. Tan pi by 4 is 1. And tan 2 into pi by 4. 2 into pi by 4 means pi by 2. Tan pi by 2, that will tend to infinity. So it is of the form 1 power infinity. When we directly apply the limit, we are going to get 1 power infinity. So we can write this as e to the power limit extends to pi by 4 g of x. What is g of x? Tan 2x into f of x minus 1. F of x is tan x minus 1. Okay. So now that's equal to e to the power limit extends to pi by 4. Now for this tan 2x, we know the formula. What is that formula? 2 tan x divided by 1 minus tan square x into tan x minus 1. Tan 2x and you are now it's that I can switch to cancelling that x plus minus 2 tan x minus 2 minus I wrote this e. Please, guys, it's not working. Yes. Okay. So now you have pi by 4. Tan pi by 4 is 1. Minus 2 divided by 1 tan pi by 4, which is 1. So minus e minus 1 or 1 by e. 1 by no. Okay. Then since f I can say fn of a gn of exists and are not equal for some n. Further, if we say f of a g of minus f of a minus g of a into f of x plus by then the value is okay. So they have mentioned that f of a is equal to g of a is equal to k, and their nth derivatives fn of a gn of a exists. Nth derivative exists means first derivative exists, second derivative, that means f dash of a is defined g dash f double is so now the nth derivative and are not equal for some n. They are not equal. Fn of a and g. F of a is equal to g of a. That doesn't mean that f dash of a must be equal to g dash of a. Not necessary. Okay. So further, if limit extends to a f of a into g of x minus f of a minus g of a into f of x plus g of a divided by g of x minus f of x is equal to 4. Is equal to 4. Then the value of k is okay. Let's try to evaluate this limit now. Limit extends to a. Well, we shall evaluate this limit and see what we get. F of a g of x is divided by. We apply the limit. Given that the derivative is different, must be continuous. As you know, this function is continuous. So I can directly apply the limit here. We are going to get f of a into g of a minus f of a minus g of g of a into g of a here g of a. Given that f of g of a is equal to g of a is equal to k, they have given. Therefore, these two also gets cancelled. Minus f of a plus g of a, and these two also gets cancelled. So we will get 0 by 0. When we apply the limit, we are going to get 0 is a terminate form. So we shall use L'Hospital's rule. So if I am using L'Hospital's rule now, limit extends to a f of a into g of x. There f of a is constant. Differentiate g of x. You are going to get minus the derivative of f of a is x we have, so it's derivative of a which is c. Derivative of this is of derivative is g dash of x minus f dash of x. Now apply the limit as extends to a. When I apply the limit as extends to a, what do we get? F of a into minus g into f dash of divided dash of minus f. So given that is equal to k, so of f of a, g of a, I'll substitute k into dash of a minus k divided by g dash of a minus. So I'll take k. So if I take, what will remain? G dash of a minus f dash of a. So that g dash of a minus f dash of a gets cancelled. K will remain. The value of this limit is equal to k. And what they have given on RHS 4 they have given. So that k must be equal to 4 is the concept of the option. Okay. Then the next question is question number 64. The function f of x is equal to 1 plus x whole power 5 by x for x not equal to 0, and it is e power 5 for x equal to 0. is dash at x equal to 0. Is it continuous? Is it left continuous? Right continuous? Cannot be determined. Okay. Let us see how this function is defined. This function is defined as f of x is equal to 1 plus x whole power 5 by x when x not equal to 0, and it is e power 5 when x is equal to 0. Okay, so we need to check whether it is continuous or not. In order to check whether it is continuous or not, let us evaluate this limit. Limit extends to 0 f of x. That is equal to limit extends to f of x 1. That equal to, read this as, so now as x approaches 0, 1 plus x to the power 1 by x will become e. You know that formula. It will become e. So this value will be equal to e to the power 5. E to the power 5, which is also equal, which happens to be the value of f of 0. So limit extends to 0, f of x is equal to f of 0. Therefore, the function is continuous at x equal to 0. A fairly simple problem. Okay. So let's have a look at question number 65. Limit extends to 1 by 1 minus x minus 3 by 1 minus x cube is equal to. If we directly apply the limit in the first term, denominator becomes 0, which means that expression will tend to infinity. Second term also, denominator becomes 0, so that will also tend to infinity. So it's of the form infinity minus infinity. Okay. See, now what is the factor that is causing that denominator to be 0? When x approaches 1, that 1 minus x becomes 0. So that 1 minus x is causing all the problems. So you take care of that 1 minus x, then you'll get the solution for this. So how do we take care of it? You take that as common. 1 minus x cube. Okay. See here, can be factorized by using a cube minus b cube formula. A minus b into a square plus ab plus b square. Okay. So this is what we get. Now I'll take that 1 by 1 minus x as common. Limit extends to 1. 1 by 1 minus x as common. What will remain then? If I take 1 minus x as common, we are left with 1 minus 3 divided by 1 plus x square. Okay. So this is equal to limit extends to 1. 1 by 1 minus x into 1 plus x square. Here you get 1 plus x square minus 3. Okay. So this is equal to limit extends to 1. I can take this out because that will not be 0 directly. We are going to get 3 in the denominator. So it will be 1 by 3. I can write separately. And so 1 x square into divided square 6 minus 2. Okay. Now this will also be 0. This will also be 0. 0 by 0. As x approaches 1, this factor becomes 1 by 3. So I will directly write that as 1 by 3 into. Here, if I am applying the limit, I am going to get 0 by 0. So getting 0, prefer L'Hospital's rule. That will give you 2x plus 1 divided by minus 1. Apply the limit as extends to 1. 2 plus 1, you get 3 divided by minus 1. Let's just check whether it is there in the options. Yes, it is there. So 65th, the second option, minus 1 is the correct answer. Okay. Have a look at question number 66. Limit extends to 0, 3 sin x minus sin 3x divided by x into tan square 2x is equal. Here, if I directly apply the limit, I'm going to get 0 by 0. But using L'Hospital's rule is not such a good idea in this case, because just look at the denominator, there is x into tan square 2x. Differentiating it will take more time. So instead of that, I'll use the formula for 3 sine 3x. Sine 3x, you know the formula. Do you? I think you know. Okay. Those who do not know, please note down. Sine 3x is equal to 3 sine x minus 4 sine cube x. This is the formula we have. Substitute 3 sine x minus 4 sine cube x divided by x into tan square 2x is there now. In the numerator, here we have tan square 2x. In its denominator, we would prefer 2x whole square, okay, into 2x whole square. So why did I divide by 2x whole square? Because tan square 2x is this. If you have tan 2x, we want 2x in the denominator. Now you have tan square 2x. So its denominator must be 2x whole square, so that as x approaches 0, that tan square 2x divided by 2x whole square can be written as 1. Okay. So this much will be equal to 1. Right. So then here 3 sin x minus 3 sin x, that gets cancelled. Limit x tends to 0. 4 minus and minus plus 4 sine cube x divided by 2x whole square, that is 4x square into x, 4x cube. As x approaches 0, sine cube x by x cube becomes 1. So 4 by 4, that is also equal to 1. Hence, second option is the right answer. Okay. 69th question. Limit n tends to infinity. 2 into 3 power n plus 1 minus 3 into 5 power n plus 1 divided by 2 into 3 power n plus 3 into 5 power n is equal. Earlier we had solved one problem of the same kind. Okay. Limit n tends to infinity. 2 into 3 power n plus 1 is there. No, I'll write that as 3 power n into 3 minus 3 into 5 power n plus 1 is there, which can be written as 5 power n into 5. 2 into 3 power n plus 3 into 5 power n. Oh. Limit n tends to infinity. I'll take 5 power n as common. So if I take 5 power n as common, here what will remain? 2 into 3 is 6. Into 3 power n by 5 power n, I can write that as 3 by 5 whole power n. Minus 15 will remain. 15 into 5 power n is there. 5 power n we have taken as common factor. Denominator also 2 3 by 5 whole. So this one gets cancelled. As infinity whole power n and 0. Why? Fraction is when the fraction is 1. And if the power tends to infinity, then the value of that fraction will go to 0. If the fraction greater than infinity, then that value will tend to infinity. Okay. So will be 0. As it tends to infinity, 3 by 5 whole power n becomes 0. So the answer is 2. Okay. Let's start with the question. If f dash of 0 is equal to 3, limit x tends to 0 x square by f of x square minus 6 into f of 4x square plus 5 into f of 7x square is equal. Okay. So they have given that f dash of 0 is equal to 3. F of 0 they have not given. Now x square divided by f of x square minus x square is equal to. If we directly apply the limit, numerator is 0, no doubt. Denominator, I'm putting x as 0. Derivative of 6 square, which is 7 square. Now, I will have both the numerator and denominator. So x is minus 4 x 20 dash of plus as common and cancelled. So 75, that will give you dash of 7x. Okay, so after x, now you apply the limit as x. So that's 7 f dash of 0 3, that is 136. Okay. Vineet says that if we put f of 0 as 3, f of 0 is not 3, they have given f dash of 0 as 3. Okay, f dash of 0 is equal to 3, they have given f of 0 is, we don't know what it is. So whatever it is, you just observe here, 5f of 0 plus f of 0, that will give you 6f of 0 minus 6f of 0. Whatever may be the value of f of 0, 6f of 0 minus 6f of 0 must be 0 only. Okay, and f dash of 0 is 3, that I'm using here. 35 f dash of 0 minus 24 f dash of 0 plus 35 f dash of 0, together 36 minus 24. We get 12 f dash of 0. F dash of 0 is 3. 12 into 3, 36. So 1 by 36 is the answer. Okay, just concentrate. The last problem of the day. 73rd question. If the function f of x is equal to e power x square minus cos x by x square for x not equal to 0 is continuous at x equal to 0, then f of 0 is equal to, it is continuous at x equal to 0. It is continuous at x equal to 0 means limit x tends to 0, f of x is equal to f of 0. Right. They have given that it is continuous. So then what is the value of f of 0? They are asking. Oh. So limit x tends to 0, e power x square minus cos x divided by x square. If we directly apply the limit, e power 0, that is 1, minus cos 0, which is also 1, 1 minus 1, 0, 0 by 0, an indeterminate form. Okay, so I'm using L'Hospital's rule. The idea of e power x square is e power x square into 2x. The idea of minus cos x, so it will become plus sin x. Square. In the first term, 2x gets cancelled. Sin x by 2x. Now apply the limit as x tends to 0. E power 0 will give you 1 plus sin x by x becomes 1. There is a 2 in the denominator. So 1 plus 1 by 2, which means 3 by 2 is the answer. 3 by 2, which is the second option. Okay, so by 2 is the answer. Right? Okay, students, with this, I'll stop today's class. If you now, those who have understood everything can leave the meeting, and those who have any doubts, please stay back and ask through chat box. 62, 62, 62. Is equal to, and that is fn of a gn of x is and are not n. If limit extends to a f of a g minus f of a and f of x g of a divided by g of x minus f of x equal to 4. Okay, so they have given f of a is k, g of a is k. Substitute that first. Okay. In place of f of a, I shall substitute k. In place of g of a also, I shall substitute k. So you'll have limit extends to a, k into g of x minus k plus k into f of x plus k, right? Minus k into. Okay. So k minus, so that's limit extends to a k equal to k, and then non RHS what they have 4. So k equal to, okay. After the next doubt is question number 65. 65. Limit extends to 1 by 1 minus x minus 3 by 1 minus x cube is equal to. Okay. Here 1 by 1 minus x first term I have kept as it is. Second term 1 minus x cube is there now. I am factorizing it by using a cube minus b cube formula. A cube minus b cube is equal to a minus b into a square plus ab plus b square. So 1 minus x into 1 plus x square. Okay. After that, this 1 minus x from the denominator I have taken common. Then in the first term 1 will remain. In the second term minus 3 by 1 plus x square will remain. Okay. So limit x tends to 1, 1 by 1 minus x. Here I have taken LCM 1 plus x square. So this numerator will be 1 plus x square minus 3. Okay. So then what I am doing here is I am just splitting this 1 plus x square I am taking out, and there I'm considering this as a product of two functions. Whenever we want to apply the limit for the product of two functions, we can apply the limit separately and then we can multiply. So limit extends to 1 by 1 plus x square I will take. And another factor is limit extends to 1. Here on simplification, you get x square plus x minus 2 divided by this 1 minus x. Okay. So here, first factor, look at this. When x approaches 1, this 1 by 1 plus x square becomes 3. So 1 by 3 we get. Second term, when we apply the limit here, we are going to get 0 by 0. 1 plus 1, 2 minus 2. 0 divided by 1 minus 1. That is also 0. 0 by 0. So I am using L'Hospital's rule, differentiate it. Derivative of x square is 2x plus the derivative of x is 1. 2x plus 1 minus derivative of 2 is 0. Divided by, we have 1 minus x there, whose derivative is minus 1. Now apply the limit as x tends to 1. That will give you 2 plus 1, 3 in the numerator, minus 1 in the denominator. Already there is a 3 sitting in the denominator. This 3, that 3 gets cancelled. So you get the answer as minus 1. Okay, then. So the next doubt is 47th question. 47. Okay, limit extends to infinity, x into cos pi by 8x into sin pi by 8x is equal to. Okay, so look here, it looks like sin theta into cos theta, but 2 is missing. See, why do I need 2? Is because if I have that 2, then 2 sin theta cos theta can be written as sin 2 theta. That 2 is missing, so I will multiply and divide by 2. So then 2 sin theta cos theta becomes sin 2 theta. 2 into pi by 8x will give you pi by 4x. Okay, as x tends to infinity, pi by 4x tends to 0. So this x I have taken out, which taken to the denominator, which will become 1 by x. Here in the numerator, we have sin pi by 4x. So in the denominator also, we would prefer pi by 4x. So 1 by x is there, but pi by 4 was missing. So I have multiplied and divided by pi by 4. Now, as x tends to infinity, pi by 4x will tend to 0. Therefore, this factor sin pi by 4x by pi by 4x becomes 1. Okay, so 1 by 2 into pi by 4 will give you pi by 8. Okay, after that, the next doubt is first problem. Okay, first problem, it's very simple. Take this x inside, it will become x square. X square into x square is x power 4 plus x square a square minus root of x power 4 plus a power 4. Now rationalize it. Rationalize it. Multiply and divide by root of x power 4 plus x square a square plus the root of x power 4 plus a power 4. Multiply and divide by that. Numerator, it looks like a minus b into a plus b, which is a square minus b square. So that will give you x power 4 plus x square a square minus x power 4 minus a power 4. Here x power 4 gets cancelled. So you have x square a square minus a power 4. Denominator, take x power 4 as common. If I take x power 4 common and take this x power 4 outside the root, it will become x square. Inside the root, you will be left with the root of 1 plus a square by x square. Plus, here also I am taking x power 4 out. So when it goes out, it will become x square root of 1 plus a power 4 by x power 4. After that, I will take x square as common. You will have a square minus a power 4 by x square. So this x square, that x square gets cancelled. As x tends to infinity, a square by x square becomes 0. So we are left with a square by root of 1 plus root of 1. Root of 1 plus root of 1 is 2. A square by 2 is the answer. Okay, so Another doubt is, sir, does LH rule, I mean, L hospitals rule follow product and quotient rule? No, no, no. While using L hospitals rule, you have to differentiate. See, suppose if you have, let us say, limit extends to A, f of x by g of x. If you are getting 0 by 0 or infinity by infinity, then this can be written as limit extends to A f dash of x divided by g dash of x. But your g of x, or let us say your f of x, this itself is a product of two functions. Suppose this is a product of two functions, then you have to use to differentiate whatever you need to do, you have to do. So you'll have to use product rule to differentiate this. 65th question. 65. Just now I have explained, Radhika. Okay, any more doubt there? Okay, students, I think I have clarified all of your doubts. Okay, that's it, I think. Okay, so with this, I'll stop today's class. Thank you. We'll continue tomorrow. Further, if you have any doubts, ask me in our WhatsApp groups.